Hi folks, I'm back today with another project. What I have here are our powered window blinds. Now these blinds were installed by the previous owners of the house, and while they're very convenient, it's nice being able to just push a button and have the blinds go up and down. They are powered by this battery bar that takes 8 AA batteries. This battery bar lasts maybe 20 up and downs. We're constantly going through batteries. One of the great things about these blinds is that this battery bar is attached via a simple JST connector. This isn't any kind of proprietary connector, this isn't anything special, it's just a regular old JST. So there's nothing to stop me from taking this JST connector and wiring it to a 12-volt wall power supply. Crimping these connectors gave me a lot of trouble when I was getting started. And if you're struggling, I think I have a few tips that might make it easier for you. Here are two reasonably priced crimpers. The pair on the left were free in a DuPont connector kit. The ones on the right were about $25, made by a company called iWis. Both of them are low budget options and both claim to crimp connectors for wire gauges 32 to 20. And the yellow ones even support larger gauges up to 10. However, they're very different tools from a usability and build quality perspective. So there's a saying, it's a poor workman that blames his tools, but in this case, a lot of the blame really does lie in the tool. So now the yellow crimper. The yellow crimper is a plier style crimper. Basically it uses a plier action with specifically shaped teeth on the end to do the actual crimping. But as you can see, even fully closed, there's a lot of gap between these teeth. It's machined poorly, it's not aligned well. Even if you align the crimp end and the tool and the wire all perfectly, you will still end up with a poor crimp since there's so much gap here in the teeth. Now the iWis tool is levered with jaws that move in parallel to each other. This allows a more precise machining and there are no gaps or misalignments in the teeth. In addition, the ratcheting action lets you squeeze and align the crimp in and then really clamp down and ensure that it's fully crimped. And sure, you can get by with both crimp tools, however, this one will be frustrating. You'll likely have to clean up and finish the crimps with some needle nose pliers, and you will definitely have more failed crimps. You don't need to spend a lot on a crimp tool. However, you do need to be aware that there's a wide spectrum of quality in budget crimpers. I'll leave links to the iWis below. However, since these were free in a kit, I don't think I have a direct link to something of this quality, we'll say. This may not come as a surprise to most of you, but there is specific wire you should use on these smaller crimp ends. There are two things you should look out for. First, the crimp ends will indicate the gauge of wire that you need to use. You may be able to get away with something a little bit smaller, and possibly but less likely a little bit larger. However, you're best to stick with what's on the box. Second, for most crimp ends, you want to stick with stranded wire. When the end is crimped, the wings fold over into a heart-shaped pattern, and each side of the heart grabs different strands in that stranded core. Solid core wire is more likely to shift into one or the other side of that crimp end, so you're only really getting half of a crimp. Or worse, it may lock itself in the middle, and then when you try to crimp it, it'll actually end up bending and kind of folding the wings, and you'll end up with just a bad crimp overall. In addition, stranded wire is pliable. It bends and folds easily, so it'll better conform to the pinch of the crimp. Solid core wire is more stiff and brittle. Over time, the solid core wire may bend back the crimp a bit and lead to poor connections. So now, solid core wire is extremely useful in many scenarios. For small electronics work, you often don't even have to crimp a pin on the end of the solid core wire, as it'll fit right into a breadboard slot. Or even a pin header, without having to put any end on it at all. Solid core wire is harder to bend, but once you bend it, it stays in position, making it great for small, precise hookups. But for small crimp ends, stick with stranded core. So when you look at the crimp ends, you'll see two sets of wings. This rear taller set and that set is made to clamp onto the insulation of the wire, which provides strain relief. So if you tug on the wire, it's not tugging on the connection point, it's tugging on the insulation itself. And then the front wings clamp onto the core and actually provide the electrical connection. So when you feed your wire through the crimp, you want to trim it so that there's plenty of insulation for these rear wings to grab onto, and then plenty of core for the front wings to grab onto. So here is the tip I was telling you about. When you're actually doing the crimping, there's a lot going on. You're holding this crimp in steady, you're holding this wire in exactly the right place, and you're putting it in the exact right place of the crimp tool. So there's a lot of precision, there's a lot of things that can go wrong. So what I do is that when you're getting ready to crimp, don't just tear the crimp end off of the ribbon. Leave it attached. Trim the ribbon. So that you have a tag to hold on to at the rear of the crimp end. So now with that tag in, when I feed the wire into the crimp end and get it positioned exactly where I want it, I can continue to hold it with my thumb and my index finger as I feed it into the tool itself. So now the tool has two sides. There's a larger side and a smaller side. Both have that same kind of heart-shaped top. However, the larger side is used for crimping the insulation, and the smaller side is used for crimping on the core. So now when I feed this through the crimper, I'm going to press it against the bottom of the crimp tool, and I want to align the wire crimp section with the front teeth, the smaller teeth. So that looks pretty aligned. I can crimp this down. Make sure it's crimped all the way. And as you can see, the insulation is grabbed by the rear teeth, the core is grabbed by the front teeth. Everything looks good. I can snap off this little tag end. Simple. Now the real test of whether your crimp was successful is whether it fits into the housing. And there we go. So 7 more crimps and about 60 feet of wire later, and I have working blinds again. There is a third blind to the right that is receiving power, however there's an issue with the limit assignments, so it's misbehaving at the moment. So hopefully these 3 tips will help make your crimp successful in the future. I'll leave links to the crimp tool that I'm using, as well as the wires and the connectors and stuff that I use for this project in the description below. And I'll see you next project. Good luck.